So the first thing we're looking at is just a basic exponential function, e to the power of x, and we need to find the indefinite integral from 0 to 2 for 4 e to the power of x dx. So it's good to write down the formula. Yes, it is above here, but I always like to write it out. Alright, at this point I know that the 4 is a constant out the front, so I can bring that out the front here like this. Like that, and now we can look at integrating it. So the 4 is going to stay out the front. If you look at the formula, ex stays as ex, and then we have 2, 0. Now remember, when you're integrating a definite integral, you got to find your e to the power of 2 and then minus your e to the power of 0. So I'll do it in colors. We're going to do red for this one, and we're going to do blue for this one. So we keep 4 there. We then get e to the power of 2, and we subtract e to the power of 0. Once you've done that, we can simplify it down, so we get 4 e to the power of 2. Now remember, anything to the power of 0 is 1, so that becomes 1, and there you go, we've just found our area. If we look at our next one here, we have integral of a to the power of x. Alright, and we need to find the indefinite integral of 7 to the power of 3x. So again, I like to write down the formula. Except this time we're going to make a modification. Notice how there's a 3 out the front, so I'm going to put a b there, and we put a b there and a b there. Okay, so this is a modified formula. And what we do is we can write out what they are. So we know a is going to be my 7, b is going to be 3, and then we can go on and substitute into the formula. So we get 1 over 3 log, or ln, 7, and then 7 to the power of 3x plus c. Alright, and that's it, we've done that one. Now we're looking at the chain rule formula. Now with this one, again, we'll write out the formula a little bit bigger. Now this part is a bit tricky because we've got 2 e's, we've got this one here and this one here. So I'm going to color code these. So we've got in, let's say blue, e to the power of 2x minus e to the negative x, and then we've got dx. Alright, now that we've done that, we can use the formula for both parts. So if I'm focusing on the blue, because the 2 is at the top, that's my a, so I get 1 over 2 e to the power of 2x. We then have minus, we've got e to the power of negative x, so we get 1 over negative 1, e to the power of negative x, and then we always finish with our plus c for an indefinite integral. Alright, now that we've got that, we can simplify it down. Blue is going to remain the same, it can't be simplified down. This 1 over negative 1 can change to negative 1. So we end up with negative 1, and 2 negatives make a positive. So we end up with plus negative x plus c. Alright. So here we have to evaluate in the exact form this integral. So again, I'm going to write out the formula. And what we need to do here is we need to integrate that up there. So I'm going to rewrite it for 1, 2e 3x plus 4 dx. Because 2 is a constant, I can bring that out the front. So I get 2 integral e 3x plus 4, which fits a little bit more neatly with the formula above. So at this point I can start to just convert the integral. So I get 2. My a is 3, so I get 1 over 3 e 3x plus 4, and our range is 4 to 1. Now I will change those colors because I like to color code this next step. That could be 4, that can be 1. So down here I get 2. 1 over 3 e3 times 4 plus 4 minus the bottom, so 1 over 3 e3 times 1 plus 4. Now we want exact form, so we're going to focus on simplifying this down. So that front part becomes 1 over 3 e to the power of 16 minus 1 over 3 e to the power of 7. Notice how the 1 over 3 is common, so that can come out the front. So we get 2 over 3 e to the 16 minus e to the 7. E to the 7 is also common. And there you go, in exact form.